let us understand about the kinds of functions. A function f from x to y is defined to be 1, 1, or sometimes it is also called as injective function if the images of distinct element of x under f are distinct. That is, if I pick up two elements, say x1 and x2 belonging to capital X, then their images will be equal only if they are equal. If that is not happening, then we say that it is many to one. Okay, I repeat it. For every x1 and x2 belonging to capital X, if we have f of x1 to be equal to f of x2, then that would tell us that x1 is nearly equal to x2. If that is not happening, it's not going to be 1, 1 at all. It's going to be a many to one function. Yes? Now let us see some examples using the Venn diagram. We have a x and we have a y. Elements of x are x1, x2, x3 and x4. Whereas elements of y are a, b, c, d and f. And x1 is related to a through f. x2 is related to b. x3 is related to d and x4 is related to c. Let us consider yet another situation. I shall name it as xy for every situation. So the elements are x1, x2, x3 and x4 on x, and a, b, c and d to be the elements of y. So x1 is related to b, and x2 is related to c and x3 is related to a. Also x4 is related to d, and we define the relation as G. What do we observe here? We observe that f and g are 1, 1. We observe that f and g are 1, 1. For every element belonging to the x, there is a unique element belonging to y. The image of each and every element in x is unique. Now consider the situations of the two Venn diagrams which are to come, namely H and K. Now here again I consider two sets x and y. X to comprise of x1, x2, x3 and x4 now. Whereas y is to comprise of a, b, c, d, e and f. Here we see a situation where x1 and x2 are related to a. x3 is related to b and x4 is related to c. We name this relation as H. Now consider yet another situation of x and y. We name this relation as K. x1, x2, x3 and x4 belonging to capital X, and small a, b, c belonging to capital Y. Here x1 and x2 are related to small a, x3 related to small b and x4 related to small c. observe that there are two elements being related to a element in Y. So H and K are many to one functions. Now let us understand one more concept, which is surjective functions. Function f from x to y is said to be onto or surjective if every element of y is the image of some element of x under f. That is, for every y belonging to y, there exists an element small x belonging to x such that f of x is equal to y. Thus, the functions g and k are, I repeat it, thus the functions g and k are onto functions. There is one last function to be defined, bijective function. A function f from x to y is said to be bijective only if it is both 1, 1 and onto. So, in the above functions that we defined, f, g, h and k, we find that the function g is both 1, 1 and onto. So, we define that a bijective function is 1 if it is both 1, 1